In this example, we have a device. Actually, there is a hanger, which is expressed in yellow one. This hanger is attached some structure. As you see, hanger is attached by this bolt, inside bolt, and it is assembled to gazette outside the round. This round gazette is over there. Okay. For the moment, please forget the upper part at all. Just do not consider at first. The yellow one is attached to the gazette by bolt and nut. And this one, the fluorescent one, is washer. When you assemble something, then washer helps to distribute easily concentrated force to different area, wide areas. That's why we frequently use this kind of washer. In the mechanics machine element design class, maybe you can understand, you can study more about this kind of washer function. Okay, anyway, at this moment, please forget this washer. And here mainly, this hanger is attached to this gazette by bolt and nut. And after that, let's think about upper part. These gazettes are attached to the ceiling on the top of the ceiling by using two bolts. 1, 2. Okay. In this problem, our question is to find maximum value of P. What's the maximum value of P? Okay. And there are some consideration or some assumption for simplicity. We neglect self-weight here. Then problem is much easier. And another consideration, when you think about this hanger, at this point, allowable stress is this one, but if it goes up there, there is a hole like this one, then up to this point, then we have different allowable stress like this one. And when you consider bolt, we use bolt here, 1, 2, bolt 3. In bolt 3, allowable stress is sigma allowable 3, and allowable shear stress is given as well. For the bolt, allow 4 is given. Okay, in order to find P max value here, we think about many different locations. At first, we can think of at this point, when you think about gazette, then firstly, just to think about here. And at this point, tension is acting to this surface. Then when we think about just maximum allowable stress, then we can find some value, allowable force. That's the point 1. And next point, at this point we can think of also maximum stress, maximum force, because at this point we have different allowable stress. And another point here, when you think about here, then we apply so-called shear force can be applied to gazette. But I think at this point we have enough distance, enough length, then maybe it doesn't play important role. Next one, we can think of this kind of bolt, inside bolt, this bolt. Actually, when you consider bolt, when force is acting down there in this direction, then some kind of shear stress, shear force is acting to this position, this area. Then we can apply maximum allowable shear stress. Then we can also calculate allowable maximum forces by this constraint. Next one, finally, we can think of bolt head here. Actually, this bolt, the gusset is attached by two bolts. Then bolt head, we have some shear force here. Then we can apply this condition as well. Next, finally, we can think of this kind of cross section. But in reality, it's not so important because it is different from bolting condition, or how you can tightly assembled here. If it is tightly assembled here, actual diameter, this diameter of bolt, maybe it's not so serious. But anyway, in worst case, we can think of the diameter of this bolt. Okay. We thought about many different cases. Firstly, one, and this position, and shear force, and here also shear force. At this point, shear force, we thought about that, and tension here, we thought about that. We can think about that. Then when we calculate every case, the worst case, that's the consideration point for finding maximum value for external force P. Okay, that's the general consideration related to this problem. Okay, now let's think about this point. When you cut there, then this kind of consideration is available. When external force is given, then it can be divided by like this one. Then if it is calculated and it is compared to maximum allowable stress, then we can find maximum force. And near the bolt position, at this point, we have different level of maximum allowable stress. That's why we consider this cross section. Okay, we've just thought number 1 and number 2, and next one we can think of another cases. In the case of bolt, when you consider a bolt, when external force is located like this one, then forces are distributed like this one, upper and down, and this cross section, we have so-called shear force. Okay, shear force is divided by 2 shear area, and this area in another side area, then we can have this kind of relationship. Okay, next, when you consider bolt on the top of bolt 1, 2, we have okay, external force is located like this one, then half of them, half is acting for each bolt. Then we have this kind of consideration, and we have some consideration between this surface, and finally maybe we can think of this case, but I already told you it's not so serious because it depends upon how it tightly assembled to the ceiling. If it is very tightly, it is attached to the ceiling, it doesn't make any sense. But it is not so tight, then maybe maximum force, maximum diameter should be considered. Okay, now let's go back to this position, the original problem again. In the case number 1, in this case here, P1 can be calculated. P1 is divided by area. Area is B1 and thickness 1, BT. This one is what? Sorry, this one is what? Sigma 1. Okay, we can compare sigma 1 and the maximum allowable, stress. Then we can find maximum allowable P1. Okay, and tension and compression's case, we can apply this kind of relationship. That means at this position as well, at this position also, maybe here 6, this position as well. Okay, similar method, we can calculate every position. And when you think about shear force, in this case, when external force is P like this one, shear area is actually the diameter phi over 4 d squared. We have two shear area. Okay, this one is A. Let's say bolt 3. And shear stress tau equals what? External P is divided by A, B, 3. And trouble is we have two shear areas. Then introduce 2. Then we can find here shear stress. And this one is compared to allowable shear stress. Then we can find the maximum P value. Okay. In this case, we applied it to this bolt, but when we apply another side here as well, toe of the gusset, and here head of bolt, we can apply there. Then we can find the maximum P value, and we can compare P1, P2, P3, P4, P5, P6. Then finally, the worst case, then we can select that value. That's the maximum allowable external force for this device. Okay. I repeat again, we have this kind of systems. A hanger is attached to the gusset by bolt. The gusset is attached to the top of the ceiling by 2 bolts. That's the system. Gusset is like this one. When you see from this side, then we would like to find the maximum allowable stress force Pmax. And in order to find that, we can think of each position. This position, P1 position, and in the middle here, because we have different allowable stress, and here as well, and here shear area and bolt on the top as well. Of course, here in the bolt, inside the bolt, we consider everything. And finally, we can calculate each maximum allowable force, and we can compare each other or one another. Then finally, the worst case we can determine. That's the maximum allowable value for external force. Okay, that's the example.